welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or you want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI pipelines, they just launched dedicated CPU instances. In addition to that, they just launched a new data center in Toronto, and they've got one opening in Mumbai at the end of 2019. Go to pythonpodcast.com/linode, that's Linode today, to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of the show. And to keep track of how your team is progressing on building new features and squashing bugs, you need a project management system that can keep up with you, that's designed by software engineers for software engineers. Clubhouse lets you craft a workflow that fits your style, including per-team tasks, cross-project epics, a large suite of pre-built integrations, and a simple API for crafting your own. With such an intuitive tool, it's easy to make sure that everyone in the business is on the same page. Podcast.init listeners get 2 months free on any plan by going to pythonpodcast.com/clubhouse today and signing up for a free trial. And you can visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And if you have any questions, comments, or suggestions, I'd love to hear them. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host, as usual, is Tobias Macey, and today I'm interviewing Harry Percival about domain-driven design and enterprise application architecture in Python. So, Harry, could you start by introducing yourself?
Hi, Tobias. Thank you very much for having me. So my name is Harry. I'm a Python programmer from the UK. I've been doing Python for maybe 10, 11 years. And at the moment I work at a sort of furniture retailer or design brand called Made.com, and we sell kind of furniture and other homewares throughout the UK and Europe.
And for anybody who hasn't encountered you before, they might know you from your Obey the Testing Goat book or from your fantastic jokes at various PyCons.
Yeah, sure, that's right. So my previous career, or my previous job before this, was at a startup called Python Anywhere, which is a kind of Python hosting platform as a service type of thing. Even before that was a company that morphed out of a spreadsheet company. It used to build a kind of Python-based spreadsheet, like Excel, but with Python as the kind of scripting language, which is really cool. And I joined them as a kind of an intern during my second degree, and that is now 2009, I think. And they were an extreme programming shop, so they did XP, they did test-driven development for absolutely everything, they did pair programming on everything. And basically, after a couple of years of that, I wrote a book about it, which was called Test-Driven Development with Python, just saying, for self-taught programmers, here's a kind of really structured, rigorous way to approach coding. Test first, incremental, version control, all this good stuff.
And I'm wondering if you can just share how you first got introduced to Python.
Yeah. So actually, when I mentioned spreadsheets, while I was kind of paying my way through my university degree, I had a client, and I would basically help him build these spreadsheets, which were like pricing models that he would use to go out to do competitive tenders for legal services. And like the lawyers would insert like these spreadsheets, which would say what kind of prices they would do for different things. And then having been doing this degree in computer programming for a couple of years, I eventually said to him, we could stop using spreadsheets and we could build this as a web application, and people could like submit their pricing, and then we could have a UI for clients to go and find the best price and stuff. And that was my first kind of real consulting engagement, my first real programming client. And he said, that sounds good, I trust you. And he says, tell you what, since you've never really built a website before, why don't you call up my hosting company and get them to just support you, at least provide the hosting and give you some advice. So I called them up and I said, hey, what's up? I thought I was going to build this thing. And they're like, right, well, we use Django, so that's what we recommend you use. And so I said, okay, I'll give it a go. And so I think it was just before Christmas, I went home for the Christmas break with a copy of Dive into Python and a copy of, I think, the original Django book, and basically read those two things over the Christmas holiday and sort of came back having taught myself Python and Django as best I could in the space of kind of 2 weeks. And I was off to the races.
Yeah, that's definitely one of the great things about Python and Django in particular, is that it is approachable enough where that's something that's feasible, as opposed to if you had gone home with a teach yourself C++ book and whatever passes for a web framework in that community. I'm sure it probably would have taken a bit more than just the one Christmas break to be productive.
Right. I mean, it's so often in the case in the Python world of I say to people who are just learning it, oh gosh, I have to learn this whole programming language, and I just say to them, actually, especially if you already know a bit of programming, the way Python does it is kind of the most straightforward and intuitive way you can think of. Like what's the simplest and most obvious way I could do a for loop? I want to iterate through all the items in array. How about for item in array? And like literally those words. Colon, and so many things like that. It's all about Python's strength in saying there should be one, preferably only one obvious way to do it. Yeah.
And so in your work of building applications and supporting other members of your team and working in these extreme programming environments, you appear to have gotten bitten by the bug of being interested in application architecture and the concepts of domain-driven design. And I know that architecture is a very broad term. It encapsulates a lot of different ideas and potential approaches and design patterns. And the concept of enterprise application architecture is something that grew largely from the Java community. And so I'm wondering if you can just start by describing what you mean when you're talking about application architecture and how it compares to some of the typical types of design patterns that Python developers rely on.
Yeah, absolutely. So I'm a bit scared of the word enterprise. There is a subject called enterprise architecture, and that's really about building a strategy for a large company for how are they going to evolve their portfolio of applications from their, what's in-source, what's outsourced, what do they buy off the shelf, and there are people called enterprise architects that kind of build technology strategies for big companies. And that's kind of, in a smaller company, that would just be the role of the CTO. So I'm not here to talk about enterprise architecture. And I'm really talking about application architecture, insofar as everyone agrees on that bit of terminology. And to sort of explain what that is, design patterns is a thing. So people might have heard of design patterns. Is that, although there's a kind of, and I'm talking about architectural patterns, and are they the same thing? Not really. So design patterns, which are, the classic Gang of Four book, was about sort of giving you suggestions for how to build particularly code in the object-oriented paradigm. And it's things like singleton pattern, abstract factory, blah, blah, blah. And lots of people out there in the Python community have spoken a bit about design patterns, and particularly saying the way that, something like 40% of those patterns that are famous and from that book aren't really applicable in the Python world, because in a way, they're workarounds for features of the Java language that are just not really necessary in the lovely dynamic world of Python. So I'm not here to talk about design patterns. I'm talking about application architecture, and I suppose application architecture is a level of abstraction higher than design patterns. And it's about saying, how do I build my application as a whole? How do I decide how to structure my code? How do I decide how to split it up? How do I decide what code to put where? And to make that more concrete for people, one of the most common architectural patterns that people have heard of is MVC, Model View Controller. And so the idea is I'm going to split my application up into a kind of model, which talks about the data and the way I model the data. And then I'm going to have some views, which is how do I present the data to the user. And then I'm going to have some controllers, which are going to say, okay, well, given that the user asks me to do these sorts of things, how do I control, orchestrate, put together that request with things from the model and build a response back for the user. That's Model View Controller. And then in the Django world, that translates more or less to the way Django asks you to structure things into models, which represent database objects, and templates, which are the kind of views of data, and what Django calls view functions, which are maybe more equivalent to controllers and MVC. But they're both examples of a layered architecture, which says, I'm going to build my application in layers. There's going to be the lower layer of the data stuff. There's going to be a kind of middle layer of business logic and controllers. And there's going to be a presentation layer at the top. That's the most well-known and familiar architectural pattern, probably.
One of the interesting things about the idea of application architecture is that there has been a bit of pushback on the idea of upfront design with the advent of things like agile programming and the idea that we're trying to move away from waterfall, where you put everybody into a room for days or weeks, you write out everything about how the software is going to operate, and then you just go and spend all of your time building it exactly to that specification, which, as we all know, never works out the way that we plan. And so we've kind of gone to the extreme other end, where rather than putting in a decent amount of thought into how everything needs to be modeled, we just say, we're just going to start writing code and we're going to figure it out as we go and everything will be wonderful, which also doesn't usually work out. And so I think as an industry, we're starting to oscillate back to a middle ground of actually having some of this upfront design, trying to get an understanding of the domain that we're working with, but still being able to approach the actual implementation in a agile and iterative approach. And I'm wondering what, in your experience, are some of the influences in general, whether in team dynamics or industry dynamics, that tend to lead engineers into suboptimal architectures that end up becoming brittle or coalescing into the dreaded big ball of mud, and some of the ways that you can potentially guard against those influences?
Yeah, there's a bit to unpack there, but I guess if the idea is, okay, let's not worry too much about design up front, we're just going to be agile, let's build something as quickly as you can. The way we do that is we pick a framework like Django, and Django's tagline is the framework for perfectionists with deadlines. And so it's saying, here's a thing, it's going to get you up and running really quickly, and it's going to let you meet some deadlines. And so I'm not going to think too much about architecture, I'm going to pick this framework. But what you've actually done is picked an architecture without thinking about it. And so Django is pushing you towards this kind of layered architecture with kind of models and views and templates. And that's fine, and it's very successful, and it gets you to a lot of places very quickly. But I think it does run into some problems as things scale. And I think in the Python world, we're starting to see some of the problems that other languages and other communities have been through a long time ago. And so once, if you're just building a startup and you're building a web application and you're up and running for the first couple of years, Django is great and Flask is great and whatever it is. But after a while, you can run into the limitations of that simple three-layered architecture. Firstly, because it's not always even that easy to stick to that three-layered architecture if you're not thinking about it. But even if you do, you can run into problems. And so any application that grows to a certain level of complexity, if you don't have a sort of reasonably structured way of thinking about, okay, well, like, where am I going to, here's a new bit of functionality, where am I going to keep the code for this? Where is the place that's going to make it easy to maintain, that's going to make it testable? Then you will end up with a slightly haphazard approach, and you're going to end up with the classic problems of the increasing complexity of applications. The kind of the jargon is the big ball of mud, where everything kind of depends on everything else, and that making changes in a sort of one part of the system over here is hard to disentangle from places over there. Or you just find yourself, due to the architecture of your framework, finding that your tests are just getting slower and slower. So it might even be that your application is quite well structured, but your test suite that used to run in under a second is now taking an hour and a half to get through CI. Or, in the case of Python Anywhere, which is admittedly a bit of a unique case, but it was taking, half a day. I'm not saying that's, particularly because Python Anywhere made bad architectural choices. It's a very unique case. But what I'm saying is, what works really well at a small scale, you can start to struggle with as you grow.
And so one of the core concepts in the problem space of application architecture that has been adopted by more mature organizations and language communities is the idea of domain-driven design, which has proven fairly successful in terms of being able to support large applications and large organizations, as well as some of these evolutionary and iterative cycles of development practice. And so I'm wondering if you can just unpack the term there and some of the benefits that it provides to software architecture in general, and some of the core concepts that are necessary to get introduced to that approach to application design.
Sure thing. So domain-driven design is a kind of a philosophy for how to build applications, but also how to approach your conversations with your stakeholders, with your business, so the kind of requirements gathering side, as well as just the coding side. And the central conceit of it is that the most important part of an application is the model of the core domain, the core business domain, which, maybe you'd use the word business logic or business rules, or the representation of the problem space. And that is the piece that delivers the most value. And the conceit is saying, like, if we get this right, if we have a model that really does capture the essence of the business and the way it does things or the way it understands the world, then that model will be really easy to understand for both the business and developers. The application will be in sync and in tune with the business, so it's going to help them do their jobs more. And it may also even enable possibilities that people didn't even realize were there. So if I've done a really good a job of modeling the business, I may suddenly be able to say, hang on, this concept and this concept, we can now bring these things together. And did you realize that we could do this and sell this product in this way, or deliver this service in this manner? So that's the central conceit. Is the most important thing is modeling the domain. And so domain-driven design is a series of kind of techniques and methodologies and ways of coding that try and bring that to the front. Having conversations with the business and trying to build what he calls a ubiquitous language. So business people have jargon. If developers sit there and try and really understand that jargon and understand nuances of it, get rid of ambiguities, and then they can decide on single words to define concepts in a certain context, then you can have the code and the way that you talk to your business be the same, so that when you say sales order, everyone understands that is an order from a customer, not an order from the company to China to get a piece of furniture or something, for example.
There are some other approaches to software design and application architecture that have gained some level of popularity, and I'm wondering if you can just briefly outline some of the other common approaches and why you think that domain-driven design in particular is worthy of additional attention and exploration for people who are working in the Python space.
Well, I guess what you'd contrast with it is sort of letting things evolve naturally over time. And I think what I've found is, in my experience, I've worked at some places where there isn't really a domain. Like your Python application is a very thin layer over a database, really. We're just letting people create, read, update records. So is there a complex domain with a lot of business rules there? No. Well, in that case, maybe you don't need to go to the full extent of building a complex model. Right, and so I think the ways that this gets more relevant in the Python world is as our applications start to be more than just kind of data pipelines or glorified shell scripts, or if you look at Dropbox, that was basically just building a UI around a file system on a server that wasn't in your house. Like, it's a web UI over a file system. So, to a certain extent, there wasn't much domain there for a while, although I'm sure as that's grown in complexity, they've grown their own way of thinking and talking about these things, and there is one now. But I guess that's what I'm saying, is it's something that really pays off when you have a business domain of sufficient complexity that the conceit of domain-driven design, which is that the modeling the domain correctly is what will give you the most value, is true. Perhaps it's a bit of a self-referential argument, but I think you can see what I'm driving at.
And so domain-driven design is something that brings with it this idea of, as you said, there is a business domain that you're trying to be able to model effectively, but there might be situations where the project that you're working on is small enough scope or with a small enough number of people where you feel, I can just go ahead and code something out in an afternoon. It'll do exactly what I want. It's never going to evolve beyond this. Is that just a logical fallacy and everything ultimately converges towards a big ball of mud? Or do you think that there are actually cases where domain-driven design is just more effort than is absolutely necessary for a particular type of project?
No, I think absolutely it can be more effort than you need to go to, and like if the very fact if it's all about having conversations with domain experts, so like that you're finding experts in the domain and having a conversation between you and your programming team, and if you sit there and are asking the question like, who is the domain expert, then if there's no domain expert and it's just you, then there's probably nothing to it. Similarly, I guess one of the you mentioned other architectural patterns. I suppose one of the things that is kind of related to DDD is microservices, which is very much the kind of buzzword architectural pattern of the moment. And I just came back from a conference called MuConf, which is kind of short for microservices. And that's it was actually the merger of a DDD conference and a microservices conference. And the two have meshed together very well. And that's because one of the main concepts of DDD is trying to identify bounded contexts. So if you have a big enough company, there's not one domain model. The company has different capabilities. It needs to be able to, it needs to be able to invoice customers. It needs to be able to purchase inventory. It needs to be able to sell it to customers. It needs to be able to do after-sales service. And your conception of a customer can be different depending on what context of the company you're talking about. And DDD has always said one classic mistake is to build a single class to represent your customer and try and make it serve all of the use cases in the whole company. And pretty soon your customer object is unbelievably complicated and hard to maintain. And it has fields called slightly different things for different cases. And it's because it's used everywhere, it's hard to modify because you impact every single area of the company when you try and modify the customer object. And that in the Django world, it's the sort of giant user profile kind of anti-pattern. And what DDD says is, listen, what you need to do is identify bounded contexts where you've got a sort of reasonably coherent piece of business functionality, a reasonably coherent domain. And what you're going to do is model that domain and not the other ones. So like, what is the user as far as sales orders are concerned? That's one thing. And then over here, what is the user as far as, monthly billing is concerned? And it might be a different concept. One might have an address, the other one might not. And they would tend to say, let's isolate those concepts, and then the two should be reasonably independent. And if they ever need to talk to each other, we'll have a translation layer. We'll have a way of translating the user as far as sales orders are concerned to the user as far as invoicing is concerned. But we want to keep them separate. And that can work in the context of a monolithic application, but it also obviously ties in very nicely with the idea of saying, actually, maybe my sales order service and my invoicing service, parts of my application should be different services. They should be microservices. And then you can get into splitting hairs about how tiny a microservice should be, but it is something that fits very well with trying to talk about decomposing monoliths or trying to talk about like what makes a single coherent application. So application architecture in this sense of deciding what is an application, what should be multiple applications. Hope that made sense.
Yeah, that made good sense. I definitely think that one of the valuable pieces of DDD in general is this focus on understanding what are the boundaries of the different problem spaces that I'm trying to encapsulate within my application, because it's definitely all too easy to say, oh, I've already got something that does 3/4 of what I need. I'll just bolt on this other piece that isn't really part of the core concern because it's fast for me to just get it out the door. And that's what starts leading people towards this big ball of mud, because they just say, oh, I'll just bolt something on here. Oh, this already isn't quite exactly what the semantics are sort of implying it's supposed to do, but I can just spend 5 minutes getting this working instead of a day and a half redesigning how this is going to work and, future-proofing against some of the accretion of technical debt that would happen otherwise.
Yeah, absolutely. I mean, we've always got this tension between, trying to anticipate future problems and build a design that is going to manage complexity for the future and make our lives easier and maintainable, and just saying, Yagni, you ain't going to need it. All right, yeah, fine. Maybe if I was building some huge piece of enterprise software, then it would be really sensible to put all these layers in and build all this indirection. But I'm just trying to build, a social network for pet owners. I don't know. I'm just trying to build my little thing. Is it not really worth it? Or how do I know that it's now is the right time to start being rigorous and disciplined about architecture? I don't have any magic answers to that. But what I do have is some suggestions for, okay, people in the world of DDD, which is, often the world of Java and C#, have been doing this kind of modeling of business problems for years. And they've come up with all sorts of ideas about how you build a model and the kinds of problems that you're always going to encounter and some classic solutions to it. So these concepts like, in your classes that represent your model, distinguishing between, and there's some jargon here, I don't know how much detail we want to go into, but distinguishing between value objects that have no identity over time and are replaceable, and entities, which are objects that represent something in the real world that has an entity that varies over time, even though its attributes may change over time. And finally, aggregates, by saying, well, I've got lots of classes in my model, I'm going to put some individual models to be in charge of a bunch of others, and they're going to be the only way of modifying the state, so that I have a single object or class that's in charge of my consistency rules, my invariance, my integrity rules. So promoting some of your models to being kind of public models in the same way as you have private and public methods. And you can hear that there's kind of language and ways of thinking that have come out of the OO world, which we're all a bit suspicious of in the Python world. When someone says to me, private methods, I'm like, the whole point of Python is that we're grown-ups. Nothing is private. You can put an underscore in it if you want, but I reserve the right to look at that. But these things that all exist for a reason, and once you have a certain level of complexity, these kind of patterns and tools for managing complexity really do come into their own. And the nice thing is that when you do them in Python, you don't have to sit there writing public, static, void, main, and all the kind of Java verbiage. You can have this kind of quite lightweight way of building abstractions and building a structure into your application that doesn't feel as heavyweight as some of the things you get into with interfaces and whatnot in Java.
And I think that this is a good point, too, to start digging into the actual implementation details of some of these patterns, because as you were mentioning, there are these ideas of interfaces where I have this sort of abstract base class that says that any class that inherits from it is going to have these types of methods. So as long as I have something that implements the actual business logic behind them, then I can plug this in anywhere, which then feeds into the idea of dependency injection or inversion of control. And so in the Java world often means that there is some sort of dependency injection framework, and I have seen various attempts to port those ideas and even very Java-esque implementations into the Python community or the Python landscape, which usually doesn't translate very well. And so I'm wondering if you can just talk through some of the ways that you approach these ideas in Python that leverage the native capabilities of the language while still maintaining the core benefits of the ideas without necessarily catapulting somebody into Java.
Yeah, right. Well, so I guess it's time then to talk a little bit about dependency injection and the closely related and more important topic of dependency inversion. So one of the patterns or rules of thumb, and I tell you what, Bob Martin has been popularizing this recently, so people who've read Clean Architecture, which I hasten to add that I haven't. And maybe this is a good time to add a caveat that says, I am not an expert in this stuff. I have been learning about all these sorts of architectural patterns while I've been at MAID, which is about 18 months now. But the experts are is Bob, the lead architect here, who came from the C# world and has seen all this stuff in his previous careers. So I'm a little bit talking about things I don't fully understand. But with that caveat in mind, dear listener, the idea of dependency inversion is saying, it's this rule that says that our high-level models should not depend on details, they should depend on abstractions. And actually, some of our popular frameworks, like Django, do this for us already. They say, okay, well, listen, if I was building a model class to represent, my domain, I'm going to build a class to represent orders and a class to represent customers and whatever, I know that at some point I'm going to want to save that to the database. So the kind of naive way of doing that is to say, okay, well, let's have my model kind of import and do a bunch of SQL code, and it will know how to save itself to the database by writing some raw SQL. And then my model depends on a detail, because the specific dialect of SQL and the specific database that I've chosen, or even the fact that I've chosen to persist to a SQL database rather than a NoSQL database or to the file system, is a detail. It's an infrastructure detail. It's an implementation detail. And you can build code where your high-level modules, your domain should be the highest level module, depends on infrastructure details. And the dependency inversion principle says, well, let's flip that on its head. What we want to say that, our model shouldn't depend on the database. It should depend on an abstraction. And then the database can depend on the abstraction as well. And that's what Django does. It says, okay, well, your model doesn't know about the database directly. It knows about an abstraction, which is the Django models.model class. So we already kind of are used to doing this, and it's about taking it to the next level, really. And it's saying, okay, well, even though your model maybe depends on the Django models.model class, it still depends on some sort of infrastructure. Yes, your framework, has made it easy to swap Postgres for MySQL, but you've still got a dependency there. And so when you want to run all your tests, you have to instantiate some sort of database. And some of the architectural patterns we're talking about is saying, well, let's really invert that dependency all the way and say, rather than having the model depend on the database, even if it's an abstraction of the database, let's have the model depend on nothing at all. And instead, we'll have the database look in at the model. So instead of my model class is importing django.db.models, I'm going to have some sort of database module import my domain model and say, okay, if I want to build my database, let's go and have a look at the models, and we'll figure out which tables will map to which columns the other way around. I'm not sure if I've explained that very well. Tobias, maybe you've got some questions.
No, I think you did a good job of talking that through. And for anybody who wants to dig a bit deeper, we can provide some links to maybe some visuals that will make it a little easier to grok, because something like this is definitely hard to encapsulate fully just through a podcast. And also, we haven't touched on this yet, but you are working on a book that is intended to cover a lot of these different topics. And in the process of preparing for this conversation, I was reading through bits of it, and I think that you did a very good job of talking through that specifically in terms of the Django ORM versus SQL Alchemy and some of the ways that you can approach it. And so I'll add links to those specific pages as well for somebody who wants to dig a bit deeper.
Great. Well, maybe that's an interesting thing to talk about, because my last book was all about testing, and these architectural patterns can really help with testing. And so I think near the end of the book, I said, listen, how do you decide how to what kind of tests to write? You could have some unit tests. If you're doing Django, you have these sort of kind of unit tests, but maybe they're going to use a real database of some kind, or even an in-memory SQLite database, but they're going to be a little slower. And we were just talking about how so that can be a bit of a break on development. You can have integration tests where you're going to check the boundaries between your systems, like, can I really talk to a database? Can I talk to a third-party API? Whatever it'll be. And you might have end-to-end tests where, if you follow my book, you're going to drive a browser with Selenium and use a real database. But, even if it's just an API, you're actually going to spin up some containers and a thing that looks like your production system and test end-to-end whether everything is really wired together. And we started talking in the book about, okay, well, how do we decide what kind of tests to write and how many of which ones? And we know that the end-to-end tests are the ones that give us the most reassurance about our system working, but they're also the slowest. So they give us the slowest feedback and the least information about whether our design is correct. And we know that the unit tests are the fastest, and they give us the most feedback about like individual low-level bits of design, like, is this piece of code well written? Is it easy to use? Is it easy to test? But on the other hand, you never know if you've pulled all your units together. And so, you read around this stuff and everyone says, well, the test pyramid. Okay, the answer is you want a pyramid such that you have a few kind of end-to-end tests on top. You have a sort of middle layer of integration-y tests where you have a few more of those, but not too many. And then you try and have the bulk of your application tested through unit tests. And this always seems like great advice. And then you go away and you build your Django app and you find that, actually doing that in real life is quite hard. And what I've found from some of the architectural patterns that are in use here at Made and that Bob made everyone have a crack at is that they really enable this test pyramid. By using these patterns where you can actually divorce your domain model completely from the infrastructure, by even maybe building a service layer to capture some of those kind of controller use cases, orchestration types of pieces, I can actually write unit tests for a vast amount of my application totally independently of the storage system or the specific presentation system or the specific boundaries at the edge of my application. And it's very similar to what Gary Bernhardt called functional core imperative shell, of trying to have the boundaries of your system be as thin as possible, and you write them, using whatever style you need, and you can test them with integration tests or maybe not at all, and then having the core of the application being functional, having no dependencies where you can test it with just data in and data out. And so beyond just kind of these buzzwords, functional core imperative shell, hexagonal architecture, test pyramid, like actually seeing them in practice, right, oh, okay, if I build my application like this, it really can work. I really can have a ratio of 10 to 2 to 1 unit test to integration test to end-to-end tests has been really eye-opening, and that's something that I've been excited to share with the world through the best way I know how, which is writing another book about it, like you're saying.
And so at this point, I'm sure that there are at least some people who have decided that it's worth exploring domain-driven design and trying to incorporate it into their projects. And so I'm wondering what your advice is as far as next steps for actually getting involved in DDD, and particularly when they're trying to implement it on top of an already existing code base where they might need to refactor or re-architect.
Yeah, I don't have any lovely answers to how do I refactor to get there from here. So let me just try and treat treat the questions separately. The first one is about like, oh, listen, well done, Harry. You've convinced me that this DDD thing is at least worth looking into. Where can I find out more? So yeah, by all means, there's my book. At some point, we should be publishing an early release on Safari, so that will be public, and then you can have a look at the sources on GitHub. We can share that after the show, sure. And that's a nice lightweight and Python-based introduction. Then there's classic books on DDD. I refer to them on my blog. That's at betatestinggoat.com. So the last post has a couple of links to books you can read. Now, the classic books is massive. So the so-called Blue Book, which is Eric Evans, the kind of original proponent of these ideas, it's 600 pages long. I've read about 60% of it. Everyone says it's incredibly dense. It's not incredibly dense. It's not impossible, but like there's a lot to it. And so that's the way to go if you want to go in with both feet. And then the other thing to do is start looking. There are DDD conferences, and start maybe watching a couple of conference talks. It's been so refreshing for me, having been going to Python conferences and a few open source conferences, to go to a new kind of conference where people are talking about software architecture and design. And they have all kinds of solutions to problems that we run into all the time that somehow we never seem to talk about in the Python world, or in the kind of Linuxy world sometimes.
And so once people do start going down the road of paying more attention to the ideas of application architecture and maybe using domain-driven design in their projects, I'm wondering, in terms of your experience, both as far as the projects that you've been involved with and also just talking to other people who are using similar approaches, who's responsible for actually implementing and adhering to these different architectural principles and designs? Is it just that you have somebody who's got the architect title and they are the ones who have to be responsible for all of that? Is it just the individual developer? Just what are some sort of best practices from an organizational perspective to keep everybody on the same page?
Yeah, well, I want to, like, this is obviously something that's going to be really specific to everyone's case. Like a 3-person startup is going to be very different to company like Made with 100 developers, is going to be different to a bigger one. At Made, we're lucky that we have an architect who knows how to do these things, who came along, was very credible, was a really lovely person, and was able to sort of show people, these patterns, why they work, why they're a good idea, try them in real life, and then, from experience, people were able to say, okay, this really works, let's do it everywhere. So he was able to bring things along and be a kind of mentor and coach. So that's great. And if your company has an architect that already knows these things, go ahead and listen to them and see if they're convincing in your use case. But I think it's it'd be quite dangerous to have a team in which there was just one developer who's obsessed with this stuff and was just going to do it on their own. Everybody else is just going to be baffled because there is jargon here, and to a newcomer, it's confusing. Like, what is an entity? What is a value object? What is a domain service? These are all things that have meaning, and once you know them, it's a very good language for talking about code. But if you don't know them, it's just confusing, and you're going to ascribe meanings to things that aren't exactly what they are, and you're going to get very confused. So I would suggest it's something that you have to try and adopt as a team, and find your resources for it wherever you can to try and do that all together. But the good thing is that once you do, it's very powerful because you do have this shared language, in the same way as you have a ubiquitous language for talking to the business about their requirements and how the application should grow. You have a shared language to use with your colleagues about, the application's architecture, how we describe the moving parts and where we put code. So these ideas like domain service or entity or aggregate will have meaning for everyone. And then if you suddenly start hiring a bunch of Java developers or whatever it is, they'll show up at the code base, they'll be confused by Python for 3 or 4 days, and then they'll get it because Python is so wonderful. And when they see things like entity, aggregate, repository pattern, they'll go, oh, okay, yeah, I know these things because we've used them before. So it's that's a team dynamic that's valuable as well. I hope that answers the question. Yeah, so like if you have experts, listen to them, and obviously you've got to build some consensus around it, and then the advantage of having a sort of shared jargon.
Yeah, I definitely think that that's useful because, as you said, particularly in the case where you maybe have one developer who is very enthusiastic and says, I'm just going to do it all, and then everybody else is going to have to follow in my footsteps, it's not going to end out well. It's something that requires buy-in from everybody and is a collaborative effort where you might have one person who's maybe driving the vision. Everybody needs to be on board and interested and engaged with actually implementing those details and holding themselves and their teammates accountable for ensuring that they are adhering to the sort of agreed upon designs.
Yeah, right. And so you were saying, how do I, I've got an existing application, how do I get there from here? One classic way is, splitting out a small part of your monolith and deciding to build it into some kind of microservice. And that might be a really nice testing ground for saying, okay, rather than building this just the way we've built everything else, maybe this is a place to go and use some of these architectural patterns. And if it truly is a microservice, some of those architectural patterns might be overkill. But you have a nice controlled design environment for practicing them, and you can at least start to get a feeling for the code and how it all hangs together and have conversations together so that when next time you pick off a bigger piece, you've got some knowledge. So, it's the same way as I would tell people to try out TDD is pick a project, have a sort of like contained experiment where you have a time box where you can say, well, we're going to try it. We're going to try it for this many months, not 3 weeks, but we're going to try it for a few months, really get to learn it and really see how it works in this organization. I think it's probably the same kind of approach would work well for taking on DDD and taking on some new architectural patterns.
And in terms of just overall trends in system design and application architecture, or just overall influences from the technology landscape, so things like microservices and Kubernetes that has been enabling some of that, or just general trends, I'm wondering what are some of the ones that you are keeping an eye on that you're excited for, and some of the ones that you think are potentially going to have maybe a negative impact on the ways that people design and implement their projects.
All right. 2 things, I guess, come to mind there is talking about event-driven architectures and talking about serverless versus Kubernetes. So the thing we haven't really spoken about today is this idea of event-driven architectures. And one of the things that happens at Made is that you have microservices, or at least several different services. And one of the patterns that so once you've built your microservices, you've got to decide how they all talk to each other. And the classic way is they all expose APIs and they can talk to each other over those APIs. And the other one is to have some kind of message bus. And I've seen that be very successful here. So that's definitely something to look into if you're working in microservices and you haven't or you haven't fully decided how they're all going to talk to each other. Investigate the idea of a message bus of asynchronous event-driven communication between your services, because that can work really well. And then one of the talks I saw a couple of weeks ago sort of convinced me that there really is maybe something to this idea of serverless, where even sitting around having Kubernetes, which gives us this great abstraction and way of orchestrating and managing containers, maybe still worrying about a lower level of detail than we need to. And so that's just on a personal level, it's made me slightly more open to the idea that serverless, whether it's AWS Lambda or whoever, is perhaps more than just a buzzword and the fad of the month, but maybe something quite interesting about the way we're going to build applications for the future. So you can tell I haven't really looked into that, but that is certainly something I'm intrigued by.
Yeah, serverless in general is something that I was skeptical about for a while, but I actually had the privilege of speaking with a gentleman who has founded and built the company Data Coral on a couple of recent episodes, and he has actually built his entire platform on serverless technology. So it's definitely interesting hearing his experiences about the ways that it has enabled him to approach a different way of building and deploying a SaaS application. So I'll add links to the show notes for anybody who's interested in following up on that as well. But yeah, it's definitely something that comes with a lot of hype, and I think a lot of people are probably getting a bit over enthusiastic about it, but there are some real world use cases where it can actually be beneficial and enable some different ways of designing and delivering applications.
Right. What's the classic Gartner hype cycle thing? We're in there's the something of overinflated the peak of inflated expectations and the trough of disillusionment. So maybe we've both been through the trough of disillusionment, and we're now into the plateau of whatever it's called, productivity, plateau of blah, blah, blah. Plateau of delivering shareholder value.
And so are there any other aspects of domain-driven design and application architecture or anything in general in that field that you are keeping an eye on that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, no, I don't know. Just I'm interested to see how well it starts to penetrate the Python world. So I'm talking about it, but I'm not the only person. There's an Italian called Leonardo Giordani has written a book in English, in perfectly good English, called The Clean Architecture in Python, which is talking about some of these application architecture patterns very closely related to what I'm talking about in my book. There's a bunch of crazy Russians have built a framework called Dry Python, DRY, and they have got their own view and a sort of series of abstractions and toolkits for building, for application architecture, and that again is sort of closely related to DDD. So it's, when I set out on this book, I did think a little bit, is no one going to care about this? Is maybe the Python world not doing the kinds of applications that need this? And it's been really nice actually building, having these conversations, meeting Python people at DDD conferences, talking to people at PyCon who are expressing an interest. And I think, yes, that as a community, we're starting to see the level of maturity in the, the applications that we're working on, that these kind of problems really are going to start paying off. So it's a nice space to be in. I'm really excited about it.
And so, as you mentioned, the Python community in general hasn't really latched onto a lot of these ideas until somewhat recently, because I think partly because of the fact that it is so easy to get up and running and get something functional and usable, and because of the features of the language and the sort of ease of onboarding, it's become possible to maybe extend some of these applications beyond where, if you were trying to implement them in a similar language, you would have run into the point where it starts to crumble and fall over because of just the difficulty of contorting your logic into these various shapes. And so I think that now we're starting to run up against the limitations of the Python language for being able to evolve to larger and more complicated architectures. And also the fact that Python is starting to make its way into some of these bigger organizations and larger applications. So things like Instagram is one of the examples that gets put forward, as well as Dropbox. And some of these businesses that started small with Python have grown to the point where they actually need to be thinking about these more complex architectures and design patterns.
Absolutely. And Made is in that case. This is a company that was, just a PHP shopping cart with a bunch of furniture on it, and probably about 12 employees. And over the course of 7 years has grown to like 500 people and, hundreds of thousands of orders a month. So, and still Python for the whole of their, everything after the shopping cart is all Python here. And so that's really grown from like, let's hack it together and do our best to something much more, I guess, enterprisey. And yeah, I think you're right that some of the flexibilities of Python has helped. And I think just as the language grows in popularity, we're just going to see more and more big things. So what I'm really excited to do is see if we can actually make these patterns Pythonic. Because if you ever read a book on architecture patterns, all the examples are in Java or C++ or C#. And if you haven't done Java or C++ since university, or indeed ever, I mean, they're just eye-bleeding, like you just read them and you kind of lose interest after the 15th reserved keyword for saying public static void int type main, all this stuff, which is, fine, it's a nice way of structuring object-oriented code, but when you're used to Python that just says, here's a function, here's its arguments, forget about your type hints and what's, and public and private, and like this is just the core of the code in the most terse way. Reading this Java code is tiring, and I wonder if there's similarly, like one of my hopes, we haven't quite decided on the title of the book, but I was thinking of something like lightweight application architecture patterns or Pythonic application architecture patterns, because I'm keen to show that, just because you're adopting kind of Java-y, enterprisey application architecture patterns doesn't mean that your code base is suddenly gonna look like Java. And so I'm really keen, especially now while the book is still in draft, to get people's feedback and to see, like what feels heavyweight, what feels lightweight, what feels Pythonic, what doesn't, and see if we can really, as a community, build kind of the Python way of doing these things. Because I think that's something we're so good at is kind of building conventions and deciding like all together this is the Python way that we do things. Like by convention, no one is forcing you, but by convention, we just use underscores and not camel case. And similarly, I think we can maybe build some conventions around application architecture, around some of these classic patterns, around maybe type hints as well, whether or not there's something that needs to come into it. Around, you were talking about dependency injection. What's the most lightweight Pythonic way of doing it? Do we even need it at all? I really would like to see sort of more and more people join that conversation, and I think I'm looking forward to the kinds of solutions we're going to come up with together. Not just me and Bob in our book, or not just the first draft of what me and Bob have in our book.
Yeah, and I'll definitely add links in the show notes to people who want to read through the book in its current state and provide feedback and start experimenting with the ideas there. And I'm also wondering if you know of any examples of open source or visible applications that are using the DDD approach and some of these patterns that we've talked about that people can look at as a reference to try and learn from or get involved with.
Yeah, no, I'm afraid I don't have a good answer for that. Beyond the one I've written in the book and a couple of other blog posts I've linked to, I don't have a good example of an open source application that's using DDD in that way. I think because it tends to be about modeling a domain with business experts, and so it tends to be towards the closed source world.
All right. Well, for anybody who wants to follow along with you or get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'm going to move us into the picks. And this week, I'm going to choose a book that I started reading with my kids called Dragon Pearl. It's from the Rick Riordan publishing imprint, and it's actually a sci-fi sort of spacefaring journey that incorporates some different elements of Korean folklore and mythology. So it's very interesting. I've been enjoying that so far. And so with that, I'll pass it to you, Harry. Do you have any picks this week?
Awesome. Picks. All right. Well, listen, I have kids as well. So as you probably know from experience, I don't have any spare time to read books or things like that. But I do know in my very limited time, I'll mention two things. One is that for the second time, I'm making my way through a TV show called Treme, which is the TV show that David Simon, the creator of The Wire, made just after The Wire. And it's about the city of New Orleans in the aftermath of Hurricane Katrina. So it's about a city that's been devastated by a national disaster that's trying to rebuild itself. And in my view, it's got everything that made The Wire great, and none of the kind of, but it's so much more. Because it's uplifting instead of being just kind of depressing. So in the same way as in The Wire, it's talking about, neighborhoods and characters and people from different classes and ethnicities. And it's talking about problems with corruption and the police and the way that like kind of institutions and democracy and government is dysfunctional. But it's also, so they're very much like these really good diagnoses of the social problems and political problems of America. But also it's set in this amazing town called New Orleans, where the musical and the culture around music and the culture of the town itself is so strong that everyone kind of pulls together or really just helps lift the spirit of that whole TV show. And I've never seen a TV show illustrate so well the way that each individual is part of a culture and how that influences them and their life choices, but how their choices also turn back and contribute back to that community and contribute back to the culture around them and help build it. I tear up at every show pretty much, and my whole life since watching it has been trying to figure out how I can move my family and my over to New Orleans and convince my wife that this is going to be a good idea, and that I promise you, even though it's America, we're not going to get shot. But it's we're getting there. She loves jazz too, so we've got a chance. The other thing I want, so you mentioned a book. Yeah, I'm reading a book called Why We Sleep, which has been absolutely fascinated. I saw that recommended by Rafael Pianazza, who's one of the contributors on the PyTest framework. He was really enthusing about it, so much so that I just thought, no one can be this enthusiastic about a book without it being good. So I bought it, and I've not been disappointed. It's an amazing nonfiction written by a sleep scientist about what sleep is, our best understanding of how it works and what it does. And, I'm only sort of 3 or 4 chapters in, and I'm already becoming a sleep bore and kind of going on about it to my friends and telling them the importance of sleep. But, the short gist of it is that it looks like a massive amount of the modern world's population is chronically sleep deprived. Like, we are not getting enough sleep. We should be getting about 8 hours a night. And ideally, we should be getting 7 or 8 hours a night and a 20-minute to an hour-long nap in the middle of the day. And none of us are doing that. So as a result, we are sleep deprived. And being sleep deprived affects you negatively in every single health metric that you can think of. It's bad for your heart, it gives you cancer, it shortens your lifespan, it reduces your intelligence, it reduces your motivation, it reduces your ability to build relationships, to be empathetic, to control your emotions, to enjoy life. It reduces your physical and psychological health. And that's very measurable. And so fascinating book, like an absolute polemic and a call to arms and saying, like, make sure that we understand sleep is important. Let's get more of it and let's try and understand it better. So yeah, Why We Sleep. I can't look up the author just now, but fascinating stuff.
All right. It's definitely something I'll have to take a look at. Well, thank you very much for taking the time today to join me and discuss your experiences of working with domain-driven design and building with it and helping us learn more about why we might want to consider incorporating it into our own applications. So thank you for all of that, and I hope you enjoy the rest of your day.
Oh, such a pleasure being here. I feel flattered to be on the podcast. Thank you very much, Tobias. I hope this starts some conversations. I hope to hear from some of your listeners, and wishing you all the very best. Lovely day, lovely week, lovely month, lovely rest of the year. Happy holidays. It's going to be a beautiful summer, all this sort of stuff. Yeah, absolutely. Bye, Tobias.
All right. Thank you.